Hi guys, in this every class we're going to be looking at application of modular arithmetic. In our previous set of classes, we worked extensively on the various equations under modular arithmetic, but in today's class we're going to be looking at the application of modular arithmetic. Let's see the various things that could be done with the knowledge of modular arithmetic. So right here, modular arithmetic can be divided into two major groups when it comes to application. The first we have is the simple application, and the next we have is the complex application. So we talk about modular arithmetic. The knowledge of modular arithmetic can be applied in two ways. The first way is the simple application, and the second is the complex application. So let's see the various applications under the simple application. Under the simple application, we have number one, we have time, and we have events. So the knowledge of modular arithmetic is applicable in a simple manner. And when we talk about the calendar, for example, the calendar is a very good example. The modular arithmetic is very much active when it comes to how our universe works, the days, the weeks, the seconds, the minute, and so on and so forth. So date, time, and event. The next we have angles. We talk about the compass, the blade of the compass. The compass, the north, south, west, east, the way the compass works. And we talk about angles, the knowledge of modular arithmetic also is very applicable. And also we have other basic applications or other simple applications. So now we'll talk about the complex application. These are all the major simple applications. So let's look at the complex application. So for the complex application, we have, first of all, we have encryption. Each time you chat with people, let's say on WhatsApp or Messenger and so on and so forth. Now the encryption is what helps to keep the chat private. So modular arithmetic is being used for encryption. Even when you try to enter your details on various bank apps and the rest, encryption is the knowledge. Everything is being protected. Your ID and the rest is being protected based on encryption. And encryption comes from the application of modular arithmetic. So the next we have, after encryption, the next we have is remainder theorem. That's what we call the remainder theorem. The remainder theorem can be solved using various approaches, such as, let us see the various methods that can be used to solve the remainder theorem. For the remainder theorem, we have things like Fermat-Leeto theorem. Fermat-Leeto theorem is one of the major methods that could be used under modular arithmetic to solve for remainder theorem. And the next we have is we have the Euclid method, the method used by Euclid. After that, we have a CRT, the Chinese remainder theorem. Chinese remainder theorem. And after that, the very last one, which is my favorite, we have the general theorem or method. So these four major methods or theorems, I can call them methods, are the major methods that are being used to solve for remainder theorem. Now, when we talk about remainder theorem, what are we talking about? We're talking about, the division of very large numbers. When it's time for us to see it, you're going to be seeing how we can apply all this. Now, most times, modular arithmetic come in very handy when it comes to division of very large numbers. Now, if you are asked to divide a very, very large number, numbers that look impossible, we can quickly use the knowledge of modular arithmetic using either of these methods under the remainder theorem to easily pulverize such a number. So these are the major applications. We have the simple application, daytime, event, angles, and other sort of applications. And we have the complex applications, encryption, which is used for communication, social media, and all kinds of security stuff, your banking apps and the rest. And also we have the remainder theorem. Each under them we have the Fermat-Leeto theorem, Euclid method or the theorem, the CRT Chinese remainder theorem, and the general theorem, which is my favorite. So we're going to be looking at worked examples from now on. Okay, guys, here's the first worked example for this very lesson. So we have, it is 6:30 p.m. today. What time will it be 200 hours from now and 200 hours ago? Now, look at this very first question. There's a first major question. Don't forget, we're talking about simple application. Now, under the simple applications, we're going to be looking at a couple of worked examples. Don't forget that for the simple application, we are talking about date, time, event, angles, and other sort of simple applications. So if it is 6:30 today, 6:30 p.m., don't forget p.m. post meridian, that's in the evening. So what time will it be 200 hours from now and 200 hours ago? So what time will it be? Two questions in one. Now don't forget when we talk about the time, we talk about a clock, for example. Let's say there's a clock right here. Don't forget that modular arithmetic also is a clock mathematics. So now if the time is, let's say the time is 3 p.m. If the time is 3 p.m., let's say either 3 p.m. or 3 a.m. So if the time is 3 o'clock, for example, now don't forget that if let's say the time is 3 p.m. If the time is 3 p.m. in the next 12 hours, don't forget from 3 p.m. to 4 p.m., 1 hour, 12 like that. In the next 12 hours, 3 p.m. plus 12 hours, what are we going to get? We're going to get 3 a.m. So what does it mean? It means we're going to return to 3, the same 3, every 12 hours interval. So the time is 1 in the morning, whatever the time is. By the time you go through the clock clockwise, this clockwise, either clockwise or anti-clockwise. The clockwise simply means the way, the natural way the clock goes. Anti-clockwise simply means the hand of the clock going in the opposite direction of the natural order of movement for the clock. So if the time is 3 p.m. in the next 12 hours, we're going to get back to the same 3 o'clock, but it's going to be 3 a.m. Why another 12 hours, which is 24 hours, will return us to work. Another 12 hours will return us to this 3 p.m. in the next 12 hours. Another 12 hours will return us to 3 a.m. So now the fact is, when it comes to clock mathematics, especially let's say the clock, your wristwatch, and so on and so forth, 12 is the modulo. All our operations is based on modulo 12. Very based on modulo 12. But for the fact that we are talking about AM and PM, AM means in the morning, ante-meridian, PM is post-meridian. So when we talk about AM and PM, which is another thing you have to consider. Now for AM and PM, when we talk about modulo 12 is very, very important that you know something. What do you have to note? When you move one, if the movement is one, that is odd movement. If the movement is odd, what do you observe? If the movement is odd, either you move once, you move 3 times, you move 5 times. Odd movement will change AM to PM. There will be a change. Odd movement will change AM to PM. But when you move even, from no movement at all to 2 times movement, 4 times movement, 6 times movement, and so on, even movement will change. Even movement will not change anything. This one will change, but this one will remain constant. So how do I mean? If you look at the first movement here, from 3 p.m. from 3 p.m., we move from 3 a.m., I beg your pardon, down to 3 p.m. That's the first movement. So from this 3 a.m. here, from 3 a.m. down to word, that's plus 12 hours, 3 p.m. Now from another 12 hours again, from 3 p.m. down to word, 3 a.m. So the first 12 hours is the first movement. The second 12 hours is the second movement. Now when you look at this, number 1 is odd. Now what does odd do? The odd word changes. It changes AM to PM. But it even make sure that there's no change. It's going to remain constant. So we're going to be using modulo 12. That's the standard. As you can see, modulo 12 is the standard. 3 o'clock returns back to 3 o'clock after moving 12 hours. That means 12 hour is the standard, is the modulo. So quickly, let's solve this. If it is 6:30 p.m. today, what time will it be 200 hours from now and 200 hours ago? So don't forget we are using modulo 12. So 200 hours from now, that's going to be plus 200 divided by 12. Now we're going to divide quickly. Now let's see. How many 12 do we have in 2? 12 and 2 is 0, remainder 2. So 12 and 20 will give us what? That is 12 times 3, 24. That is 1, remainder 8. So 12 and 80, what are we going to get? 12 and 80. 12 times 6, 72. 12 times 7, 84. 7 is more than that. That is 6. Remainder word. 6, remainder 8. So we have 16, remainder 8. So what do we have? We have 8 modulo word, modulo 12. But first of all, don't forget that for the fact that we are talking about what, we're talking about AM and PM. You're not just talking about the time. You're not just talking about 6:30. You're talking about either 6:30 PM or 6:30 AM. So that means it's very important the kind of word answer that we have. On the norm, we ought not to have any business with the result with a 16. We don't really care if it's 16 or whatever. We really care about the remainder. It's the remainder that we really care about. Because the remainder will determine how many more hours we're going to add to the time that we have for us to get the present time after 200 hours. But now we have to look at the answer gotten. That will determine if it's going to be in PM or AM. Now don't forget, If it is even, if it is odd, I beg your pardon, if it is odd, the result will change. 3 a.m. plus 12 hours changed immediately from 3 a.m. to 3 p.m. So if it is even, it remains the same. So what's the result? The result here is 16. 16 is even. It means it remains the same. It's not assuming it's 15. It means this very PM will become what? Will become AM. That will be 6:30 AM. So after moving 16 rounds, which is an even result, even number of movements, it means we have the same word, the same PM. So it's going to be word 6:30 PM. Why? Because of the 16 rounds of movement plus 8 hour plus 8 hours. So after 200 hours, in the next 200 hours, what do we have? 6:30 p.m. plus 8 hours, that's plus the next 8 hours, which is 8 modulo 12. What's going to be 6:30 to 12:30 is 6 hours. Then 12:30, 1:30, 2:30. So that's going to be 6:30 to 12:30. Then from there, we have 6:30 to 12:30 a.m., I beg your pardon. So that would then be 2:30 a.m. That is the result. So in the next 200 hours, if the time presently is 6:30 in the evening, then don't forget that after 16 times movement, we're going to come back to 6:30 p.m. Then 6:30 p.m. plus 8 hours, that will give us from 6:30 to 12:30 in the morning. Then from there down to 2:30. So it means the time is 2:30 a.m. So let's see what's going to be in that's 200 hours ago. If the time presently is 6:30 in the evening, 6:30 p.m., 200 hours ago is going to be what? Let's see what that looks like. Minus 200 divided by 12. So we're going to create a 12 times table moving in the negative axis. So don't forget 12 times 0 is 0. 12 times minus 1 is minus 12. So we're going to go down. Don't forget that 12 times 16, you understand, 12 times 16 gives us something very close to 200, which is 192. So we're talking about 12 times minus 16. That'll give us minus 192. Minus 192 is still bigger than minus 200. Then 12 times minus 17 will give us what? That will give us minus 204. So this is the closest to minus 200. The closest to minus 200 is minus 204. So what do we have? 12 in minus 200 will give us minus 17. Remainder. What are we looking for? Minus 200. And we went with minus 204. So minus 200 minus minus 204 give us remainder 4. So what's our answer? Our answer is 4 modulo 12. That's our result. But before we carry on, we're going to add 4 hours to the 6:30. So 4 hours plus 6:30. So what's going to be? Let's say the result. The result is odd. The result is odd. As you can see, it's an odd result, 17. So what does it mean? It means we're going to move from 6:30 p.m. down to 6:30 a.m. if it is odd. So it means 6:30 in the morning plus 4 hours. What's that going to be? 6:30 in the morning plus 4 hours. That will surely give us what? 10:30 in the morning, 10:30 a.m. So this is everything for this. So the question is very, very simple and direct. The knowledge of modular arithmetic. So instead of counting it mechanically, you can easily use the knowledge of modular arithmetic to solve this. You can see how easy it is. Very, very simple. So we come to the end of this very lesson. In our next other lesson, you're going to be looking at more worked examples. I'm very sure that you gain 1 or 2 things from this very lesson. I'll allow you to give me a follow on Facebook at Revelation and subscribe to the very channel at Edge Mosaic. And please share this lesson also with others. See you in the next lesson. Thanks and bye for now.